Hi everyone, my name is Paul. I'm a PhD student at the University of Melbourne. My project is about measuring and modeling the impacts of irrigating urban green spaces on surface energy balance and microclimate. And today I'm going to talk about part of my PhD project. And this work is also contributed by Professor C.Y. Jim from the Education University of Hong Kong, Professor Nigel from Monash Universities, and my two supervisors, Dr. Kerry and Professor Stephen Lipsley. Um, Most of the work in the literature about cooling urban green spaces is about public green spaces. But in certain cities in the world, private green spaces can contribute to 30 to 50% of the total urban green spaces. So it is important to look at the microclimates of private green spaces like backyards. They're important because they are a convenient place for people to socialize and relax, and they are also a safe place for children to exercise and get exposed to nature. However, our world is getting warmer. Last month, July 2023, was the warmest month ever recorded in history. And the problem of having a warmer climate is that people's willingness to stay outdoor will decrease with increasing air temperature. Traditionally, we know that planting trees is highly effective in reducing air temperature and improving thermal comfort in cities and urban green spaces. But some of the backyards, private gardens in the new residential housing in Melbourne and many other cities in Australia are getting smaller. These backyards and gardens are not, there's not enough space in these gardens to plant trees, so we need to look for an alternative cooling strategy. And irrigation is one of them. This study here is a modeling study that predicted the potential irrigation cooling effect of in a suburb in South Australia. They predicted that if you irrigate 30 millimeters per day, you can get a 2.3 degrees Celsius cooling overall a daytime value. To understand how irrigation affect microclimate and induce a cooling effect, we need to look at the surface energy balance. Of course, it is a very simplified version. Um, as we all know, when radiation comes hit the ground, part of it is reflected, and the rest is available to drive three different processes. First, warming the air. Second, evaporation and transpiration. And third, warming the soil. And these are sensible heat and latent heat and soil heat. In the case of low soil moisture content, a larger part of the energy goes to sensible heat. That's why we have warmer air temperature. And when the soil moisture is higher with irrigation, latent heat is larger, such that we have a smaller sensible heat. So the predicted effect of irrigation is that we will have a small sensible heat, lower air temperature, and maybe higher humidity. So heat fluxes are very difficult to measure. So in my experiment, I will look at the impacts on microclimate, air temperature, humidity, and so on. In my PhD project, I use a field experiment to look at the impacts of irrigating a small backyard. We built these small areas of which are 6 by 6 meter, and we installed a climate station in the middle. Some of them are irrigated, some of them are not. So when we compare the irrigated ones to the unirrigated ones, we can understand the impacts of irrigation. I have to emphasize here that irrigation for cooling urban green spaces is different from the traditional irrigation that we all know. The irrigation that we usually talk about is for improving plant health, and we usually irrigate by night because we want to reduce direct evaporation and improve water use efficiency. The irrigation that I'm working on is for cooling urban green spaces. And in that case, I can irrigate by day or by night. Um, the goal of such irrigation is to maximize evaporation and transpiration because these are the two processes that we get the cooling benefits from. And in traditional irrigation, using potable water can be justified because it is important to keep the plants alive. When we use irrigation for cooling urban green spaces, ideally we should use recycled water or rainwater. In this experiment, I have two specific hypotheses. First is that irrigated turf is significantly cooler than unirrigated turf during the day. And secondly, I want to look at how irrigation amount will influence the cooling benefits. I look at irrigating 2, 4, 7 millimeters per day. The study period lasts for 35 days in December of 2021. There are 4 plots in this experiment. They refer to the 0, 2, 4, and 7 millimeter irrigation per day. And to deliver the water, we use 5 nozzles, 1 at the center and 4 at the corners. We have adjusted the nozzle such that the water doesn't heat the climate station. And at the center, we measure a number of microclimate variables. And this graph shows the results. The x-axis is the week after irrigation started. I'm only looking at week 2 to week 6. And y-axis is the daytime mean difference in soil moisture or microclimate variables between the irrigated plot and the unirrigated plot. So we are looking at the difference between the irrigated plot and the unirrigated plot. In terms of soil moisture, we can see that the difference in soil moisture between the irrigated plot and the unirrigated plot increased from week 2 to week 6. And that is actually because of the drying of the unirrigated plot. From week 2 to week 6, the irrigated plot basically the soil moisture there remained at about 40 to 45. So the increase here is actually driven by the drying of the unirrigated plot. And second, the differences in soil moisture between the 3 irrigated plots is quite small. They are very similar. You can see that the 3 lines representing the 3 irrigated treatments are very close, and that is because there was a large rainfall event at the start of the experiment. But still, we can see that there is a huge difference in soil moisture content between the irrigated plot and the unirrigated plot. So we can look at what the impacts of this large soil moisture difference. From in this graph, I look at the difference in air temperature between the irrigated plot and the unirrigated plot. And we can see that the cooling effects were significant, which is denoted by the open circle. And secondly, the cooling effect, the daytime mean cooling effect in the last week was quite significant at negative 0.8 degrees Celsius. However, the differences between the 3 treatments were small because they had very similar soil moisture content. By comparing the previous 2 graphs, we can see that as the soil moisture difference increased, the air temperature cooling effect strengthened. So if we can keep the soil moisture of the turf higher, we can get a stronger cooling benefit. Putting that 0.8 degrees Celsius in context, we can compare it to the cooling benefits of trees in Melbourne. In Melbourne, trees can reduce air temperature by negative 1.5 to negative 0.7 in air temperature. So it is the cooling benefits of irrigation on air temperature is comparable to tree shade. For turf surface temperature, the cooling effect were also significant. In week 6, the cooling benefit reached 3 degrees Celsius. Irrigation has very little impact on field pressure. That is basically humidity. And irrigation has very little impact on human thermal comfort, specifically universal UTCI, and that is because irrigation did not change the most important variable of human thermal comfort, which is mean radiant temperature. We didn't have shade. So obviously, if we compare the cooling benefit of tree shade and irrigation on human thermal comfort, tree shade does a much better job. So in conclusion, it was true that irrigation could reduce air temperature and turf surface temperature, but it cannot improve human thermal comfort. For the second hypothesis, it was unfortunately not being tested properly because there was a rainfall event at the start of the experiment. But I recommended that for Melbourne, we should keep the turf a bit wet by irrigating every day, as little as 2 millimeters per day, and that would be great for keeping soil wet. Thank you very much. I would like to acknowledge the grants that I received for supporting this experiment.
Thank you, Paul. We have some time for a few questions. So does anybody have any questions? Elena will come around with a microphone. So we'll start over here.
Thank you. It was a very impressive presentation. For me, it was one of the best presentation here. You are a very happy guy because you have very good equipment, and it's a big responsibility. And your results are very important for also human models, which are largely missing data about soil moisture, about the effect of the moisture of the turf, etc. And what I want to ask you, when I remember to my PhD thesis, we deal quite a lot with soil temperature, which also missing in the models data, like the spatial variables. Have you also measured the soil temperature and, let's say, heat fluxes in the soil?
Yes, great question. Thank you. We also measure soil temperature and soil heat flux, and during the day, soil temperature was lower, and during the night, soil temperature is slightly higher, but not very significant. In terms of soil heat flux, which is very important, we measured a increase in downward heat flux during the day. More heat is conducted during the day into the soil because of higher thermal conductivity, and during the night, we had a larger upward soil heat flux. That means we also had a small warming, but not significant during the night. So, but the important thing is that we want the daytime to be cooler. So irrigation is still a desirable strategy. The data set is probably worth publishing because we have measured soil temperature and soil heat flux.
Okay, we have time for maybe one last question. Elena, is anybody still have a question for? One up here.
Really enjoyed the presentation. The question concerns the difference in surface temperature, which was impacted by the amount of irrigation. The air temperature was not so much. So the surface temperature would contribute to MRT and to thermal comfort. So on that basis, it seemed like you were recommending the lower amount of irrigation, the 2 millimeters a day. But would additional moisture result in a noticeable change in MRT?
if you remember, yeah, there is some differences between the three irrigation amounts on surface temperature. But the differences is quite small, and surface temperature is not the primary driver of mean radiant temperature.
So it's a solar radiation.
Yes.
Okay.
Well, in the next experiment, we have shown that irrigating at different times of the day with a smaller amount. I mean, using the same amount of water, but dividing the irrigation into smaller irrigation events will actually strengthen the cooling effect because of more evapotranspiration.
Wonderful. Thank you, Paul. All right. We'll move on to our